Graphing slopes. If we have the slope of 2/3 and we wanted to show the graph of that slope, as we see the graph starting at 0, 0, then we know that the numerator, or the top of the fraction, is our rise, which we either go up or down. Because it's a positive 2, we're going to go up 2, and the denominator, which is our run, has us go 3 to the right. Then we can go up 2, right 3, and there's our next point. Now we can repeat that pattern of up 2, right 3, and one more time up 2, right 3, and connecting our points, there would be the line of the graph of a slope of 2/3. What about a negative slope? If I had a negative 3/4, most important, we need to remember that negative sign goes in the numerator, or our rise would actually be going down 3 and right 4. And we need to remember that negative, again, goes in the numerator. So as I come to my graph, again, starting at 0, 0, I can go down 3 and right 4. There's my point. And repeat it one more time of down 3, right 4. And there would be the graph of a line with a slope of negative 3/4. Now, how do we know what line would be parallel to a line with a slope of 5/4? One thing to remember, that we know that parallel lines all have the same slopes. So with my first line of 5 over 4x plus 1, the graph we know would look like that. So what would be a parallel slope? The exact same slope of 5/4, but a different y-intercept, which on the second line would be at a negative 4, and there would be our line for a parallel slope to our first line, just having a different y-intercept. And as we can see, those lines would never cross. Now, what is a perpendicular line? We all can remember that those are two lines that cross each other at a 90-degree angle, or at a right angle. So if I have a slope of 3 over 2, we know that perpendicular means that the slope would have an opposite sign and a reciprocal fraction, which is the fraction flipped over. So if I have a slope of 3/2, the slope on the graph would look like this. But as I look at my new graph, my slope would be negative 2/3. So changing from a positive to a negative, and the 3 over 2 flipping over to 2 over 3. And if I draw my new line, you can see that those two lines are crossing at a 90-degree angle. Now, just some basic things to remember about slope. If we have a horizontal slope, then we know that it is a slope of 0, and the line would be a flat line somewhere along the y-axis. And the opposite, or going the other direction, would be a vertical line, or vertical slope, and that has an undefined slope, and that would be a line straight up and down somewhere on the x-axis. Now, if we have a pattern within a table with a given slope of 2/3, then I can look at my set of points and show that a movement along the graph would fit the movement of my table. So as I move along the x, as we see, each of these movements along the x pattern is a movement of 3. That fits my graph, as we see in red there, of a movement of 3 along the x-axis, or run 3. And our y is moving 2 units, which, again, looking at the graph, would be 2 units up, and there would be my graph of a slope of 2/3 that fits the graph and the table together. Now, if we have 2 points and I want to find the slope between those 2 points, I can put those 2 points within a table and again find the movement in the pattern of my x value, which for this one, from a 2 to a 4, would be a movement of 2, But for my y, I'm going from 5 down to 2, which would be a movement of a negative 3. And my slope, again, would be the change of the y on top, or my rise, over the change of my x, or my run. And we can conclude that we have a slope of negative 3 over 2.